Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Waves on Titan. So what do we see here? Well, here we see a simulation of waves on both Earth and Titan. So it's a video clip. It runs about 15 seconds, so I'm going to let it repeat so we can look at it as we go through and discuss it a little bit. But really what we're seeing to the right-hand side is a simulated wave on Earth, and on the left is a simulated wave on Titan, the large moon of Saturn, and actually the only other object in the solar system that is known to have a liquid on its surface, and that would be things like lakes and rivers. The differences are what the liquids are composed of. On Earth, we know, of course, our oceans and lakes are filled with water. But on Titan, it's far too cold for liquid water. There's water there, but it's all ice, completely frozen solid. The temperatures are insufficient to allow it to be in a liquid state. However, other compounds can be in a liquid state at these temperatures, and that includes various organic compounds and hydrocarbons that are present there. So things like methane and ethane are present on Titan and are in a liquid state. And we've actually mapped those out with various explorations of the moon, including the Huygens lander that landed on Titan. Now, when we look at these, again, we note the differences, and we can take a quick look at each one individually. But if we watch Earth, and we see the marker stick with those are meter marks on it, and we can see that it does not change very quickly, and the waves are very slow. Why? Well, it's just a very light breeze that is simulated here, and we don't get very intense waves under a light breeze. So as you watch it on Earth, you'll see that it may go up a little bit, but not even really reaching a 1 meter wave. So not a big change here on Earth. Now, if we go ahead and look at the same thing on Titan, we see it's very different. We see that the waves are much larger, and in fact, you can see as the bigger wave comes in, you'll watch that it will go up several meters in height. So 1, 2, 3 meters in height for the same wave under the same conditions. So the only thing that's different there is the conditions that are present on the two objects. On Earth, we have a certain atmospheric pressure, we have a certain temperature, and a composition of the liquid. In addition, we have a certain gravitational force. Now on Titan, gravity is much lower, atmospheric pressure is higher, temperature is much lower, and the composition of the liquid is vastly different. And that's what's giving us the different waves that we see here. Now, to study this more, there is a craft due to be launched in a couple years known as Dragonfly, which will take the 6-year journey out to Saturn and will actually study Titan in much more detail, using a helicopter-like object to be able to explore it in more detail and faster than you could with something like a rover as we do on Mars. So that's something to look forward to, but we're still looking at a decade or so before it actually gets there. So that was our picture of the day, titled Waves on Titan. We'll be back again tomorrow for the next picture, previewed to be like pearls on a string. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.